Next, we will go on to some questions and rules of thumb when you need to evaluate these significance-based research claims. And we will do this in two parts. So first, we will discuss null findings. So situations when the claim is that there is no effect or that we have not found an effect, and then the second part will be about situations where someone claims that they have found an effect or detected an effect, or that there is something to observe in this data. But let's go. First of all, the question that you should ask when there is a null finding and someone says there was no effect is how hard did they look? And often it's very difficult to find none of this effects, and statistical power is one of the things that relate to how hard you're looking for an effect. And the second question is, does this mean that if they have not detected an effect, does that mean that there was evidence of no effect or no evidence for an effect? And you might want to stop the video and consider these two phrases. Third question, does the uncertainty interval contain 0, but also very high values? So you might have heard about the confidence intervals, but in general, an uncertainty intervals would say that because it's seldom 1 point that we get out of the analysis, but we get something like instead of it being this value, it's well, the analysis indicates that it's something between these values, and if this interval contains 0, then the effect isn't usually statistically significant. But it also could be that the interval contains 0, but also very high values. So it could be that actually we have an effect that could be 0, but it also could be something very, very big. And this is important for us to know. And if you have a non-significant result, not statistically significant result, which is of course not the same thing as significant in the normal way of using the word, but you also have high statistical power. It could be that you have just calculated your statistical power by expecting a very large effect when this effect is actually very small, and so you don't have the same statistical power for detecting every effect, but the statistical power always relates to some magnitude of effect. So it could be if you get the non-significant result and you have high statistical power, there could still be an effect. It just might be that it's much smaller than you expected, doing the sample size calculations and all of that. And so our second part, questions and rules of thumb for so-called statistically significant results, where someone says that they found a significant increase in something for this demographic or something like this. So first question to ask is, well, how big is the increase? Because it's really silly to say that someone found a statistically significant effect somewhere, because you always need to know how big this effect is. Because it could be that you've just collected a very large non-random sample, and you get a statistically significant effect that has absolutely no bearing to real life because it's too small to matter in practice. And how much uncertainty is there around this increase or other effect that they're reporting? Is there a confidence or credibility interval that they report? So what's the answer? Could it be that it's probably very large, or could it be somewhere between very, very tiny and very, very large, or just very, very tiny and a little less tiny? And is this claim based on an isolated p-value or a few p-values? If so, your default option that I would recommend is that you consider this an anecdote that goes with other anecdotes, and anecdotes are can be useful information, but if the claim is based on statistical test without real background theory or mechanisms or something like this, it should be treated with the strength of evidence that they actually have. And relating to this, if you see a p-value between 0.01 and 0.05, I would consider this a weak anecdote because these p-hacking practices often push the p-value down into somewhere between these two values. And so you should look at whether it's something like this. And it doesn't need to be just p-hacking. It could be the Garden forking paths or something like this that has produced this sort of relatively weak evidence. And we've also seen in many replication studies that studies with these relatively large p-values are not replicating as well as others with more strong evidence. And if the p-value is adjusted for all the multiple comparisons, if the study is pre-registered and they actually followed their pre-registration in the analysis, and if they used random assignment and all of these things that actually make the statistical methods fit the use case, then I would consider this a stronger and we also would want to ask which of these situations seems most likely. That the null hypothesis is false and some theory you have or the author has is corroborated, so the theory gets evidence that it's more likely to be correct. So this is one option. The second option is that a rare and isolated effect has taken place. So something random has happened. So this is another option that might happen if someone produces significant results. It's always possible that they are due to chance. Or an additional option could be that the p-value is just wrong. There are selection effects, survival bias, model assumptions that have been violated, and so forth. And the result isn't really worth its worth the paper it's written. And finally, it could also be that the null hypothesis is false. So you have there is an effect, but the effect is something else that was than what was thought of. So because everything is correlated with everything else, you might have these exaggerated magnitudes, non-independence of observations, which also is about model assumptions. But and there might be variables that you haven't thought of that actually cause the link between. So if we have a variable and another variable, and and these two are not linked, if there is a third variable that affects both of these variables, they will appear linked. So these are some questions you would want to be asked. And also whether the demographic is cherry-picked out of many possibilities. So did you have, or do you think that when they show this effect in a particular demographic and they give a nice theory why it should work in this particular demographic, is it really something that they thought of beforehand or something they thought of afterwards, after they found out that actually this is where they get the low p-value? And so you remember this from the first week's lectures, where they tried to evaluate the evidence of statistical support for subgroup claims in randomized clinical trials. So there's that. And also, it could be that you have a huge survey that asks about 500 different things. And then what people can do is that they just correlate everything with everything, and then they find out, pick the ones that sort of work out, and then publish those things. So you could have a survey where people answer a question about their health, and then they answer also 50 questions about different things, and then some of these are bound to correlate with health, and so if you say that you eat a lot of pears or fish or drink a lot of beer or something like this, there is always something that if you look at just the relationship between health and some other variable, you will always find some effects. So the cherry picking could be not only of different demographics, but also from different things that they didn't report that were asked in the same form.